Good morning, sir. Good morning, classmates. I am Midshipman Grande, a third-year BSMT student of University of Antique. We are Group 3, and we will talk about blind pilotage. Blind pilotage, in the context of marine navigation, refers to the practice of navigating a vessel without relying on visual references such as landmarks or shorelines. It is typically employed in situations where visibility is severely limited, such as during fog, darkness, or heavy rain. During blind pilotage, mariners rely on various instruments and navigation aids to determine the vessel's position, course, speed, and depth. These instruments include radar, electronic chart display and information system, depth sounders, gyro compasses, and autopilot systems. Blind pilotage at sea requires mariners to have a thorough understanding of the instruments and navigation aids at their disposal. They must be proficient in interpreting instrument readings, maintaining situational awareness, and following proper navigation procedures. It is important to note that blind pilotage should only be conducted by mariners who are properly trained and certified for such operations to ensure the safety of the vessel and its crew. Planning and execution of blind pilotage. General principles. To ensure success, the ship must be accurately navigated along a pre-arranged track in comparatively unrestricted waters. This is best done by constant fixing using radar in conjunction with other aids such as DECA and echo sounder.
Good morning, sir. Good morning, classmate. For the continuation of Midshipman Grande presentation, I am Midshipman Herodias. In narrow waters and during the final stage of an anchorage delays, inherent fixing are unacceptable to the BPO. It is therefore necessary for anti-collision and navigation in these conditions to directly from the radar displays using a prepared notebook, but it is still necessary to pass radar information or fixing at regular intervals as a safety check and as an insurance against radar failure. The following principles apply. Number 1, the navigating officer should navigate or pilot the ship. Number 2, the captain should have easy access to blind pilotage position and the NO. Number 3, the ship should be conned from compass platform because it is only one the bridge that feel of the ship can be retained. Number 4, the captain, blind safety officer, OOW, and the officer in charge of the anti-collision pilot should all be careful briefed before the passage by the NO, so that they are all entirely familiar with the visual blind plan. Number 5, navigation chart with NO's prepared visual blind plan must be available on the bridge and in operations room. Number 6, the whole pilotage team should be exercised as frequently as possible in clear weather in visual and blind techniques. Only in this way can be necessary confidence in the system be built up, which will allow runs of some complexity to be conducted safety in blind conditions. Number 7, the BSO should be closed up on all occasions of entering and leaving harbor and passage through narrow waters. When special sea duty men are close up, the BP team should be regarded as part of special sea duty men. Number 8, there should be good communication between the blind pilotage position and the BSO and personal manning navigational aids fitted elsewhere. Number 9, all members of the team should be encouraged to admit any doubts they may have regarding the information acquired from sensors.
Good morning, sir. I am Midshipman Michael Postino, third year BSMT student of University of Antique. For the continuation of Midshipman Erojas. Blind pilotage planning. Number 1. A normal planning consideration for selection of tracks apply. Blind and visual tracks should be the same to enable the transition from visual to blind vice versa to be made at any time, and also to allow one plan to be used to cross the check the others. Number 2. The number of course alternation should be kept to a minimum to reduce the workload in redrawing parallel and wheel overlines. Number 3. always try to have two parallel index lines where possible, one of each side of the track. This provides check measurement, mark identification, and reveal index linear errors. Number 4. Object to be used both for parallel index line and for fixing must be carefully selected. They should be radar conspicuous and unchanged by varying heights of tide. Clearly mark on the chart the object to be used for fixing and brief the assistant. Avoid if possible fixing by radar and range bearing on a single mark. Number 5. The range scale to be used required careful consideration. Accuracy is greater or a shorter range but mark fast more quickly than a distance, requiring more lines to be drawn. When operating short-range scale, it is essential that the BPO frequently switch to a longer range to keep aware of developing situation. Change of the range scale and parallel index mark should be pre-planned and marked in the notebook. The stage at which chart will change must be carefully considered. Number 6. Tidal stream and current should be worked out and noted for calculation of course to steer and for the calculation of EP. This should be displayed on the chart and recorded the notebook. Number 7. Expected soundings, allowing for height of tide and collaboration of echo sounder, should be noted for each leg. The possibility of being early or late should also be borne in mind. Number 8. All hazards along the track and should be boxed in by clearing range and their cross index range enlisted in the notebook.
Good morning, sir. Good morning, classmates. For the continuation of Midshipman Faustino presentation, I am Midshipman Galera. 9. Details of lights and fog signals should be taken from the Admiralty list of lights chart and entered in the notebook. 10. The chart should be drawn up using standard symbols. 11. The notebook should contain the full plan, neatly and legibly recorded in chronological order. Sketches of both chart and radar display can be of great assistance to the BPO in evaluating the pictures. 12. Tracks plotted for entering and leaving harbor should not appear on the same chart simultaneously, otherwise confusion will arise. 13. Clearing range should be simple, safe, and easily interpreted. 14. Object used for wheel over should be conspicuous, easily identifiable, and suitable located adjacent to the track. Blind pilotage execution. 1. Carry out a time check to synchronize clocks and watches. 2. On the radar display, keep one set of parallel index lines drawn up ahead of those in use. Any more will clutter the display executively. Rub outlines as soon as they are finished with. 3. Identify contacts early by range and bearing from charted objects. An accurate EP is a most useful aid in identification. 4. Fixed at frequent intervals and immediately after a change of course, DR, EP ahead. A suitable fixing procedure is BPO assistant standby fix in 1 minute. BPO Roger using points A, B, C. BPO assistant writes this in notebook. 5. Blind pilotage layout of navigation officer. Notebook. BPO assistant fix now. BPO marks the point on face of display. BPO assistant notes the time. BPO then range of the marks drawn on. Display and passes this to BPO assistant. BPO assistant records the range, plans the fix, and generates fresh DR and EP.
Good morning, sir. I am Midshipman Garcia, third year BSMT student of University of Antique. For the continuation of midshipman galera, this procedure cuts the time to take a fix and reduce the rest of a cock hat due to ship movement. It may be quicker to interpolate from the range rings rather than use the range strobe, although the latter will be more accurate. 6. Ship speed. One of the factors affecting the choice of ship speed will be rate at which the BPO and his assistant are capable of dealing with the radar information, commentary, and conning advice. Maintain a steady, unhurried, and precise flow of information to the command. Distance of on-track course to maintain or regain distance and time to next wheel over new course. Present. New course clear of shipping. Adjacent marks or hazard expected lights and sound signal. Expected dip and echo sounding. Minimum dips with fixing and result of fix EP to the next alteration. Maneuvering limits. Example, 5 cables, clear to starboard, 1 cable to port, if any dump say so, and if necessary to stop the ship. 7. It must be appreciated that whatever the technique employed, a drift offline is likely to be detected less readily by radar than by visual methods. It is vital to pay attention to the echo sounder and the less dip expected. The nearest land is usually the bottom blind pilotage exercise. To improve the reality of BP exercise, clear whether the following points should not be forgotten. Safe speed should be maintained. Fixes should be recorded and plotted at the same frequency as for actual blind pilotage. A full debrief should take place on completion of the practice.
That's all for our presentation, sir. Thank you for watching.